This episode of the HVAC School podcast is made possible because of generous support from our sponsors, RectorSeal, Carrier, and Mitsubishi Comfort. And also, I've talked about this a lot, you can find a lot of the products, a lot of the tools I talk about by going to TruTechTools.com. And you can find my entire tools list of products that I think that you should have on your truck. And it's really based on the types of tools we use, and then also some feedback that I've gotten from technicians. Obviously, everybody's got their opinions about what tool's the best, and you can make your own judgments. But you can find that by looking on our homepage. You go to hvacrschool.com. There in the resources tab, you can find it there. The tool list is what it's called, and we've got links there to everything, and a lot of them go to TruTech Tools. You can get an 8% discount by using the offer code GETSCHOOLED at checkout. It's actually a coupon code down there at the bottom left. And you can actually find a wide range of RectorSeal products there as well. Just a whole bunch of different RectorSeal products, including the new RectorSeal ProFit flaring kit. So that is TruTechTools.com. And thank you to our sponsors, Carrier, RectorSeal, and Mitsubishi Comfort.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
And now your host, the guy who checks the air filter of every single hotel room right when he walks in, but still can't change his own filter when he's supposed to. Brian Orr.
Yeah, so I'm actually going with my wife to Savannah. Savannah is one of my favorite cities. Savannah and Chattanooga are two of my favorite cities. I like Nashville too. Those are Asheville too. Okay, so I like a lot of cities in the South. Anyway, so I'm going to Savannah with my wife, and we're going to be staying at a bed and breakfast. And I can assure you that if I pass a filter back return air grill or a piece of equipment that I can check that air filter, by golly, I'm going to do it. I think for those of us in the trade, I think you understand that. We're always looking at equipment and looking at, whether or not maintenance is being done. But by golly, on my own house, it is hard for me to remember to do my own maintenance. And I guess it's just when you're at home, you just don't feel like doing the things that you do all day long. I don't know what it is exactly. Maybe it's just laziness. It's probably just laziness. Anyway, thanks for listening to the HVAC School podcast. I am Brian, and this is the podcast that helps you remember some things that you've forgotten about the HVACR industry, as well as helps you remember some things you forgot to know in the first place. And today we're going to talk about reach-in coolers and freezers with Eric Mele. And I think this is a really important episode. We really jump right in, and it's a little bit of a winding road. But for those of you who find yourself in the position that you do air conditioning, but you have to do a little bit of refrigeration now and then, I think this is going to help give you kind of a flavor of that. Certainly not a deep dive, but it'll give you a nice introduction to reach-in freezers and coolers. So here we go, Eric Mele. Well, today on the podcast, I'm happy to have Eric Mele. He brought up the idea of talking through reach-in boxes and walk-in freezers and coolers and all that sort of thing. But today we're going to focus on reach-ins because that's sort of a topic in and of itself. And actually, it's a topic that my own staff, one specific technician, Jeff Crable. So Jeff, if you listen to this, I'm thinking of you in this podcast. So Eric, he's expert, knows all this stuff, and is the super tech. And
Top expert,
yeah. Exactly.
Not a expert at anything by any means, but at least we can get people thinking about what they might encounter and a starting point, basically, because I've surely not seen every type of reach-in box.
Let's start with sort of the basics. What are some of the different types of reach-in boxes that you can work on? What are some of the differences?
Well, basically, the main ones you'll see are coolers, freezers, and then ones that are specific to wine, or the three different things you're trying to achieve, three different conditions, shall we say. I mean, there may be even more than that.
So specific to wine would be higher temperature and controlled humidity?
Yeah, generally wine is looking for 55 degrees at 55% relative humidity. White's a little colder, red's a little warmer. But generally, if you're keeping both in the same, 55 is, I hate to put rules of thumb out there, but it's like a general design condition for wine.
Okay, and then, so we're going to do quick design temps, average design temps. So what are the other two then, coolers and freezers?
So a cooler is usually going to be between 35 and 40 ideally. I mean, you can run them a little colder, but you don't want to go over 40. The health department does not like when your box is over 40 and you're storing perishable food. And a freezer, usually we're keeping them more towards 0 degrees. If you need to keep ice cream hard, you want to be like 0 to -10. If you're looking at like, there's some blast freezers I worked on that are meant for like hardening the ice cream right after they make it. Those go down to like -30 really fast. But those are kind of a special application.
All right, so you got coolers, freezers, and wine. Wine being the warmest, and also with wine, and I mentioned this, but the relative humidity part is really important with wine because of the maintaining the corks, right?
Exactly. If the humidity gets too high, the corks they can swell. If it gets too low, they can dry out. None of that's good. Some of the places I work, some of these people have quite the wine collections. And it's amazing to me because most of the split wine room units I see set up are very poorly commissioned and designed. But that's for the next podcast on the actual walk-in boxes.
All right, so there are wine reach-ins as well. What type of controls do you see in a wine reach-in that would affect the relative humidity?
Actually, the critical sizing is what they do in wine rooms, whether they're reach-in or walk-in. In my area, I'm in South Florida, so if you're in other parts of the country, you might have a humidifier. I don't deal with them here. We got plenty of humidity. So typically here, it's just critical design. You want to size the unit properly, and then you usually trim it with fan speed. Like they run on an AEV typically, and you can increase or decrease fan speed to adjust your humidity as required.
Okay, so you've mentioned AEV. You just went there. Let's talk about AEV, because I think I've only worked on maybe 3 automatic expansion valve systems in my career, and that's what we're talking about here, right?
Yep, I haven't seen one on a reach-in wine box. A lot of reach-ins are still Cap 2, but we'll get into it anyway because you might see one on a bigger reach-in. But typically I've only seen them for wine, and it's basically a TXV is regulating superheat, and AXV is regulating suction pressure if we want to really generalize it down. I know you have a whole podcast on TXVs that people should watch if they really want to know how TXVs work, but AXV only cares about suction pressure. You set it, and that's what it does.
So the challenge there with an automatic expansion valve is, yes, you're going to get the evaporator temperature exactly as you want it to be, but as load changes, that's going to potentially run very high superheat or very low superheat all the way down to 0 superheat. Those are the reasons why that setup doesn't work so well and why we don't see it that often, because you can have some consequences on the equipment itself unless you have a very, very stable environment, which my understanding is that's why it's used in wine, is because generally speaking in a wine cooler, you're going to have the condenser in a very fixed temperature environment, fixed conditions, and the evaporator's in very fixed conditions. And so once you kind of get it set and you get it pulled down to temperature, there's not a lot of variation.
Sometimes you'll see condensers outside for that, actually a lot of times, but they'd recommend an accumulator for sure because, like you said, if your superheat gets too low. But they just want to keep that evaporator from freezing. That's their strategy for not frosting. They run at 35 degree. Typically, with whatever refrigerant you're using, you're running about a 35 degree coil saturated temperature. That's what you set your AXV to, and just let it ride.
Essentially, by using an automatic expansion valve, you're sort of eliminating the need for an evaporator pressure regulator. I mean, you could do the same thing with the TXV and evaporator pressure regulator, but this is just sort of a more simplistic way of doing that, right?
I suppose. I mean, I've seen every real dedicated wine room unit I've seen has been using an AXV. Not to say that I've seen them all, but you could accomplish similar results with an EPR valve. Typically, those are on like multiple evaporator applications, but you could do different things. There's weird stuff when you get into refrigeration and reach-ins and small BTUs. Like I did a split BTU system for a wine room, a split system, and it was 2,000 BTUs. So you're talking real fractional equipment at that point.
I remember doing one, probably the only real wine cellar. I know we're getting off on wine and you didn't want to do that, but just quickly.
Oh, no, it's fine.
It was a ductless air handler, like a high wall unit, tied into a medium temp refrigeration condenser. That's all I remember about it. It was new construction. It was like when I was totally green and I didn't know what I was looking at. But even at that time, I was like, what on earth is going on here?
I've seen one like that too. And I'm like, this does not seem any kind of right. And I still question the design of some of these that I've seen. But yeah, we are kind of getting into split remote condenser stuff. We're getting a little off topic, but it's fine. I mean, it's going to tie into the other podcast anyway.
What are the other differentiations then that you see between different types of reach-ins?
As far as metering devices?
Yeah, just go through your list, basically. I'm trying to guide you down the list.
A lot of the stuff I'm seeing right now is cap tube. I know that as regulations change, stuff's going to digital controllers, but a lot of the stuff you see around has been around a while and they try to keep it around. And it's really simple cap tube stuff, even on freezers. So on larger reach-in stuff, you'll see TXVs. I should probably clarify, for the purposes of this podcast, we're talking about like packaged reach-ins, not like when you're in a gas station and you have like a whole wall of reach-in doors. So we're talking about like small packaged reach-ins. Yeah, a lot of them are cap tube. Some of them will start to get TXV as they get bigger. The blast freezers that I've worked on are TXV.
Okay, we're talking about self-contained equipment, basically.
Yes.
Primarily when we say reach-in. But there are a couple distinctions, because you can have products that are reach-in that are on a parallel rack system. In a grocery store, that would be the extreme version. But then there's sort of an in-between version, too. You could have a reach-in that has a remote condenser that's just for that unit.
Like a gas station, 3 doors or whatever.
That would be a convenience store. Yeah, exactly. But here we're primarily talking about reach-ins that have self-contained compressors. They have the refrigeration cycle within them. They have the compressor, condenser, metering device, and evaporator all within that device. And so let's talk about that real quick. Where are in general, when you go to a convenience store, you go somewhere and it has a self-contained unit, where are the different components generally located for a technician who walks up and is like, where do I start on this?
If you're lucky, the condenser will be on top of the unit and you have to work off a ladder, but you'll quickly find that it's a lot easier. Sometimes the condensers are going to be underneath the unit and they'll actually be accessible underneath the unit to where you don't have to move them. But then there's also cases where the condenser is tucked in and it actually has like a spiral of refrigerant tubing behind it, and you actually slide it out of the machine to work on it. And those are the biggest pain.
So to even do any testing on it, you've got to slide it out.
Pretty much. First thing, before we go too far in, like hooking up any sort of like pressure gauge is definitely going to be the last resort on these boxes. You want to verify that everything else is clean, especially condensers. Dirty condensers are the most common problem you're going to run into with these, and that'll cause cap tube restrictions if they get too severe and run for too long like that. So, I mean, hooking up gauges is kind of the last resort. You have to do it, but you kind of don't want to.
I have to ask, so why does a dirty condenser cause a cap tube restriction?
You get a lot of heat built up in the system and it starts to break down the oil. You get higher than normal head pressures, everything's running hotter. These things already run high head pressures. I mean, if you look at some of the performance ratings on these units, they're like 4 and 6 SEER, or EER, I should say, not SEER. They're really low. They have really small condensers. They're really not worried about peak energy efficiency, at least as of the time of this podcast. I'm sure they're going to be more worried about it in the future. But a lot of the stuff you see is really, really inefficient.
Cleaning is obviously a really big piece of it, but let's say you go to a case, and again, whenever we have a system that's not working, something electrical isn't functioning at all, then that's sort of where our attention goes. So we're not going to focus on that. We're going to say you walk up to a case and it's just not maintaining temperature. And let's say it's a cooler or refrigerator, and the temperatures are rising above 40, so 45, 46 degrees. So very simple application. What do you generally do first?
First of all, it's making your condensing unit run, because you could have a bad control that's obviously not bringing your condensing unit on, which is not going to meet the box. But if you're past that point, which you probably are, then you're going to have to hook up gauges to it and see what's going on. Now, these are very small refrigerant charges, so you're not going to want to hook up a manifold if at all possible. I know there's guys out there that aren't using like Testo Smart probes and stuff. Well, if you insist on using an analog gauge, you're going to have to get a stub adapter for an analog gauge and dedicate it for that kind of stuff, so you're not losing a bunch of charge every time you hook up to it. And some of these don't even have access ports, and those are even more annoying, but sometimes you have to tap into them.
So you walk up to a unit that's not maintaining temperatures, so the first thing you're going to do, and you already mentioned this, is you're going to check all the cleaning items, right? I mean, you're going to make sure that there's nothing that's blocking the condenser, and then you're going to make sure the condenser's not dirty and clean that if that's the case. And are there any other sort of maintenance, housekeeping things you check on a reach-in before you go to the step of either using the ports that are there or putting in some ports to attach?
Evaporator cleanliness too, but just those are the basic things to check. Make sure your condenser and evap are clean, the fans are clean, because that can really impact those systems. A lot of people don't take time to clean off the fan blades adequately. And if you're going to hook up gauges too, shut it off before you hook the gauges up, because if they run low, they can easily be in a vacuum on the low side, and you really don't want to start pulling air in to hook up a gauge if you can avoid it.
Let's focus on this idea of test ports and connecting gauges, because obviously Jim Bergman and I talk about this all the time. We don't want you connecting gauges unless you have to, but if you have to, and there are no ports, then what do you typically look to? Like, what is your hierarchy of how to install ports on a system? How do you approach that?
These are kind of hated in the industry. I'm sure guys have seen them before. The mechanical access ports that you can clamp on that pierce the lines. And they'll be fine when you put them on that day, but they tend to leak later on down the road, especially if you put it on the high side. So if you have to tap it, you have to tap it. And that's the easiest way to verify, do I have a problem? But if at all possible, you want to remove those.
And removing those would look like brazing in a stub and recovering all the charge, brazing in a stub at that point. So I guess in that strategy, if you're planning on removing them, then you're basically connecting, but then you're counting on the fact that you're going to have to recover the whole charge anyway. What about those like stubs that you can pinch, those pinch off tools, and then you can add an illustrator there?
Yeah, that's another method you can do. They're usually going to have process stubs sticking off these units that were pinched and brazed already when they started them at the factory. So if you put your pinch off tool where it was already pinched and you cut it and put a stub in there and braze it, then you can put a flare block, or they actually have a re-rounding block that's basically a flare block without the countersinks in it, and open it up, and then you have a test port that's brazed in. So that's another option. You basically have to purge the air off the top in that situation, or you can just, like you said, straight up, if there's no gas in it, you can just basically braze them in at that point. The mechanical access fittings are a quick, cost-effective way to verify there's a charge issue, and then you can proceed from there. You just gotta use your best judgment of when to use them.
I also imagine that in a reach-in application, weighing the charge in and out is probably a really good tool, similar to in the automotive world. A lot of automotive mechanics, if they want to see if a charge is right, they just weigh it out and see how much comes out and then weigh it back in again. I imagine that that would be a more realistic method to use in this world than it is in the regular air conditioning split world.
Well, here's the problem with that, though. When you try to do that, you're going to have losses due to your connections of your recovery equipment and your condenser of your recovery machine. I mean, it's kind of hard to calculate exactly how much refrigerant gets lost in transmission between all of that.
Right, good point.
It's doable, but it would be very tedious to figure out what you could reasonably expect to lose when you're talking a system that might take 7 ounces of refrigerant. It's kind of hard to say. You'll pretty much know you're going to see a lot lower than expected head pressure. These things run like condensing temperatures 30 to 40 degrees over ambient is not uncommon. You'll basically know that it's not working right if it's a cap tube system by that, and if you have a restriction.
And then I imagine you can also probably watch your discharge temperature in order to have some indication if you know that the condenser coil is clean, in decent shape, and the fan spinning and all that. I imagine if you watched your discharge temperature on your compressor, you could have some indication of whether or not you have a charge problem, in addition to checking your suction temperature, right?
It's weird because a lot of these little cap tube systems, they're going to have the suction line and the liquid line, or even the cap tube, like touching each other inside of the insulation. Don't quote me on why they do this. I think it has a lot to do with not getting liquid back and trying to use it kind of as dropping the temperature of that liquid going into the machine, maybe assuring both at the same time. But you'll see that a lot. So
yeah, it's a quick and dirty way of dropping your liquid temperature and increasing your suction temperature simultaneously. It's a little energy-saving hack that they can use.
Yeah. I think it has to do with energy saving and not getting liquid back, because of these cap tube machines, they don't have receivers or accumulators. So I guess they're trying to do that to assure that they don't get liquid coming back. And like you said, the energy efficiency aspect of it, whichever one is more, I think they're doing it for really both reasons, but you'd have to talk to a manufacturer to see why. So it's really hard to look at a suction temperature and see anything that you're used to seeing. And there's also like cold wall boxes that don't even have an evaporator fan. So you're going to see really weird stuff going on the low side of systems like that because there's no airflow whatsoever by design.
Just from a practical standpoint, do you find when you're dealing with maybe an application that you hadn't worked on before? So I'm thinking specifically, I was just doing a recovery on it, but it was a floral case at a grocery store, and self-contained floral case. I wouldn't know exactly what the design temperature would be for that or what the design temperature difference on the evaporator coil would be. Do you find that you look at manufacturer specifications a lot, or what do you do in applications like that where it's a piece of equipment that you may not be very familiar with?
Oh yeah, if I'm not familiar with it and I'm having trouble with the problem, like anything else, I try to consult manufacturers. They're usually pretty good about answering their phone and helping you through stuff. So you can definitely gain a lot of ground by getting all those tech support numbers in your phone, and once you have a good idea of what to look at, give them a quick call. But I mean, the cases are usually pretty simple. I don't know about a floral case. I can't say that I've worked on one, but these, like what we're talking about here, they're pretty basic. They're cap tube systems. The restrictions become pretty evident pretty quickly.
All right, bear with me for a second because I'm going to talk to you about acid away. And acid away is almost it's almost like Kleenex. You use it when you're talking about an acid inhibitor, an acid neutralizer. And there are different products on the market that do different things. There's acid scavengers, which isn't what I'm talking about here. I'm talking about specifically the acid away product made by RectorSeal. And this is the product that we use in certain cases. Caveat, because I know a lot of you are going to get upset when you hear that we use it, because a lot of you abide by the strictly refrigerant and oil approach. I agree with that approach. In general, that's what we want in the system. But also keep in mind that, the simplicity of refrigerant and oil and the old mineral oil, world that we used to live in with R22, that's not even how it works anymore, even in brand new systems. There are additives in systems right now. It's even brand new ones that you get. There are additives that are being added. As you know, I've talked about this in the past. When Carrier had the issue with some of their expansion valve sticking, they actually suggested an additive, which was the old Zerol Ice product, rebranded. So it's not like manufacturers aren't using additives or don't understand the effects. Obviously, in general, we would like to have perfectly clean equipment that never fails and there's never any issue with it. But from time to time, that can become a challenge. And that's where these products come in. And so first thing to understand is that acid away, what it does is it actually interacts and neutralizes the acid, but it creates a salt. Okay, so it actually creates another substance that still needs to be removed. It's not like you can add acid away and it's just this magic substance that you put in and it solves all problems. What it does do is it interacts with the acids, neutralizes them, creates a salt, and then that salt is caught in a filter dryer. So when you have a compressor burnout, the first thing you need to do is follow all of the proper procedures, performing flushes, using suction and liquid line dryers of the proper type and of the proper size. But sometimes, and you know this when you test, use an acid test kit and you test, you can smell the oil, you can see the black oil, and somebody wants to salvage a unit that's say you have a unit that's 8 years old, 10, 11, 12 years old in residential cases, and somebody wants to install a compressor. Sometimes it just makes sense to use a neutralizer because you're not going to be able to get all of that acid out, and making multiple trips can be very expensive for the customer. So this is a great product for that. And what I specifically want to talk about this Acid Away product is Acid Away Pro. If you haven't seen this yet, it actually uses a copper injector as opposed to a can that you dump in, because those are always super awkward. Like, how exactly do you get that in there? Just kind of make a mess. But these new Acid Away injectors are really nice, especially if you're coming up to a system and you did the burnout protocol and now you're still seeing acid. Obviously you got to change your dryers, but then you can also use this product. You can inject it in the suction line using your liquid pressure to force it through. It's just a really nice delivery method, and it works with all oils. It works with mineral and POE being the most common, but all types of refrigerant oils. And I really like it. It's a product that we use at Kalos, at my business, in those applications. So it's not the sort of thing that takes the place of other protocols, making sure that you're following all the proper procedures, testing for acid, suction dryer, liquid line dryer, properly sized dryers, removing them from service once all the acid is taken care of. There's all these steps you have to take, but in some cases, using this product can help you get there to where you have no acid in the system. So that is the Acid Away Pro from RectorSeal. All right, now back to Eric. So now let's just talk through some of the controls and some of the other accessory components that might be inside some of these different types of reach-ins.
Yeah, a lot of the smaller ones are going to have just basically, a lot of times it's called a cold control. It's going to be a little dial that usually just says 1 through 9, and colder will be pointed to arrow, and then there'll be an off position on it at times. And that's just going to be shoved into the evaporator somewhere. And there's typically there's a straight type and a spiral type. So if you're going to keep them on your truck, keeping one of each is good. And those are just going to stop the compressor when the coil reaches a certain temperature, and then start it again when the temperature rises enough.
And Dick was saying that generally 5-degree temperature swing is pretty standard.
It's kind of hard to say because you're looking at this dial and it really just says 1 through 9 on it. I haven't actually specifically looked at temperature rises. The controls all come with different specs, and obviously you should try to get one really close to what you're taking out, or the same one if possible. But yeah, you can crank the control down and go colder with it, but they're not very precise. You know what I mean? They're not any sort of digital controller. They're just using like a charge in a bulb to operate a switch, to operate an electric switch.
So simplicity is the name of the game here. I always tend to overthink this stuff, but if you're trying to set one up, so say you replace a cold control, then are you just essentially setting it back to the same setting that the last one was, or are you sitting there and kind of watching the on and off cycles of it and monitoring the temperature of the box at that point?
Basically, the easiest way to see when those are going bad is your box is not meeting your temperature and your condenser is not running. And you turn that thing all the way to coldest and it's just not running the condenser enough to bring the box in. That's a telltale giveaway that it's your cold control that's causing the problem. So you can cross-reference it with your application or with the exact control and get one in a similar setting. Like the cooler ones will cut out in the temperatures around the teens and then cut back in. Or I don't have offhand in memory exactly where they're going to do it, but the freezer ones are obviously going to be lower.
And you were mentioning on some of these more simple reach-ins that they're just manual defrost, which that's something, I mean, I think of an old manual defrost refrigerator that you've got to shut off and defrost every once in a while. Is that what we're talking about here?
There's these cold wall cases and these cold wall boxes, and some of them are meant for displaying and serving ice cream out of. Like if you go to an ice cream shop, we actually have an account that has a few different stores. And there's no evaporator fan in these cases. They run off a cold control. And by their nature, it's a freezer, so it's going to freeze up. Ice is going to coat the walls of it where the tubing is running until it's just not effective at refrigerating anymore. So I think it's like once a week they recommend that you take everything out of it and let it completely thaw. And there's actually a drain plug that you unscrew and route it to a floor drain.
Interesting. So then that just becomes part of the customer's, like it has to be part of their regular practice. Otherwise, the thing will become a big, giant chunk of ice.
Exactly. It'll just form so much ice on it that it's just not effective at keeping the product where they want it. And actually, the blast freezers that I work on too, the manufacturer does recommend, even though they have defrost timers and defrost cycles, the manufacturer does recommend actually de-icing them once a week as well. So it's going to be manufacturer specific.
I guess it only makes sense then that these would be in applications that are not in constant duty use then. So the idea is you're displaying some ice cream here, but then you're taking the ice cream and putting it back in some other type of storage, long-term storage. And the same thing is true of a blast freezer. It's like you're not using it all the time, and so we can use this strategy. Or obviously, if it was for constant duty use, that wouldn't really work.
Yeah, and just kind of the nature of the design of the case. Maybe you can get really fancy ones that have defrost, but like I said, most of the stuff I'm seeing is pretty basic. There's a couple things I see with digital controllers on them, but a lot of it's very, very basic.
Okay, and so then in defrost, you're pretty much with reach-ins, traditional reach-ins, you really don't have much in the way of hot gas. It's either where it's fan defrost, or it's got manual defrost, like you mentioned, which would be more rare. But then commonly, especially in freezers, you're going to have electric defrost then.
Yeah, you'll have electric defrost on those. Some of them I've seen time clocks in them, but a lot of them have like a little Dixell controller in there that does basically everything. It has a couple sensors and it basically runs the whole box, and it has defrost built in. They actually have aftermarket generic replacements. You can replace a lot of the controllers with those Dixell controllers and even use the same sensors that you already have.
Interesting. Oh, well, that's good to know because I didn't even think about that. But could you also use a controller like that? Say you were having a trouble with an older reach-in and maybe the defrost wasn't working as efficiently as you'd like, and maybe having trouble keeping it to temperature, where you could actually install one of those aftermarket controllers with the sensors in order to do that? I mean, is that something that people ever do?
You can retrofit it to that type. I mean, it would all depend on the customer. I don't know if you'd have an advantage if it had like a time clock in it. I don't know if you'd have advantage as long as your time clock is working, because you could always play with your defrost there. Usually if you're having defrost issues, it's because you have a heater out.
Do you test a heater with an ammeter, or do you test it just by like it's warming up or not warming up? How do you check that?
It's hard. Some of these heaters don't draw a lot of current, and you actually have to do the old touch test on them. I've actually had a drain heater on one of those blast freezers go, and I called the manufacturer and I was asking them, like, what is the resistance on this heater? Because you couldn't get an amp draw on it, and they gave me the wrong resistance, and I checked the resistance and it seemed fine, but then I had to call them back again and they said, oh no, that's wrong, it's supposed to be this resistance. And I'm like, all right, bad heater. And they said they should feel warm to the touch. I mean, that's very subjective though, especially with calloused hands and you've been working in a freezer for a while and you basically have no feeling left in your hands. So
I imagine a thermal imaging camera would be handy in that application.
yeah, that's on my short list of tools that I really need to buy. Completely off topic, but I've seen people get into trouble on water source systems with blockages in the pipe that were pretty much undetectable without a thermal imaging camera. And you start to think you have problems in your unit, and it's a blockage in the pipe.
I think thermal imaging cameras, I've always been opposed to, I shouldn't say I'm opposed to them, I just think they're generally misused. Infrared guns, I think they cause more trouble than they're worth, but infrared cameras, thermal imaging cameras, I think have a lot of applications that we haven't considered. And I think there's a case to be made that every diagnostic technician would be able to use a thermal imaging camera. And when I think about all these different applications with, say you have even a reach-in that maybe the door seal is having an issue, if you've tested everything else and you think that it could be related to that, do you think there'd be an application there, or is that more just common sense?
For as far as a door seal goes, you'll probably see it, but I mean, it's a great tool. You don't think about using them until you have it and you use it. You point it at stuff, and I don't have one to point at stuff, but I've seen where people can just point it at things and get an idea of what's going on. Just more data that you can use to your advantage. I've been on back and forth about one. I just really don't know which one I want to buy, and I just want to make sure if I spend a lot of money on a tool that it's going to be the right tool, especially one that costs as much as those can. So that's why I haven't ended up with one yet, but I think they're a great tool.
So obviously we already talked a lot about, I don't want to go too much into defrost because we covered a lot of the defrost topics in the previous podcast with Dick. Yeah, I mean, we talked about a lot of that, but you have to have some form of, it's either time termination or you have some sort of sensor-based termination and then some sort of fail-safe or I guess is what I'm saying. You have to have some way of saying, hey, it's time to come out, or something's wrong and it's got to come out because it's been way too long, kind of a situation. Is there anything else there that I'm missing or that we missed in the podcast about defrost?
No, you didn't miss anything in your podcast about defrost, but one thing I've noticed about some of these reach-in coolers is one with a digital controller I saw actually was not running the fan continuously. And without getting too far into it, I don't know if there's sensors that deal with that or not, but you might see that a lot in the future as digital controllers become more available. Maybe they're running a coil sensor and they're not running the fan full time. So that's something to look out for. I've seen it happen. And there's also usually a door switch on the equipment that's not going to run the fan when the door's open. Just another thing to check.
So because in a cooler refrigerator, medium temp, you need to run the fan in order to defrost. If you're expecting air to defrost that evaporator coil, the fan obviously has to be running. Whereas in a freezer, it's the opposite. The fan needs to be off and defrost. Otherwise, it's going to, when that heater comes on, it's going to blow snow all over the place.
You'll definitely know it if you have a box where the fan's coming on too soon, because there'll usually be ice forming around the ceiling, around the fan. It usually sticks right there because the coils are usually mounted right against the ceiling, whether it's a cooler or a box, like a reach-in.
And then in addition to that, you've got drain heaters. In some cases, you have door heaters. Do you see a lot of door heaters in, I imagine you do, in freezers, reach-in freezers?
Yeah, you're going to have door heaters in a lot of the cases to keep an eye on and see if they're working. I mean, it's pretty obvious when they don't, your door starts to ice shut.
Indication that they're not working is door doesn't open.
Exactly.
And then if you do have a system that you have to defrost, so if you're having a defrost issue, what strategy do you generally use on a reach-in?
If you have to de-ice the coil?
Yeah, if you've got something that's
like manually?
Yeah, that's a big ball of ice.
If it's on wheels, I like to take it outside and use a hose. If it's not on wheels, then it's more complicated. I mean, usually a pump sprayer and a shop vac, and it's tedious. I prefer not to do it. I prefer to just put it over by a floor drain and prop the door open and come back if the customer's okay with that. Just unplug it. But yeah, it happens sometimes where you have to just de-ice stuff, and it's not fun. A hose is the fastest, but it makes a mess, so you have to be able to be by a really good floor drain or be outside.
Cool. What else are we missing as it relates to reach-ins?
But one thing we kind of skipped over on my list here is most of these boxes are meant to hold a product at temperature. Like some of them are not. Some of them are designed, like the blast freezers are designed to take a product that's warm and pull it down. But it's something to keep in mind, like how the customer's using it. If they're putting like hot food in there and expecting it to pull it down, you really got to check with the manufacturer to see if that's what it's intended for. And most likely it's probably not. They're just doing that. And not to say it doesn't work depending on how much you put in there at a time, but just keep that in mind is these boxes are designed to hold a product at temperature and just be conveniently located. They're not necessarily designed to take like warm product and stuff it in there and expect it to pull it down.
Right, exactly. And so let's say you do that. Let's say you take a reach-in freezer that's designed to maintain temperature and you just jam it full of a bunch of hot meat, freshly slaughtered steak. What are some of the things that you might see?
You're going to have poor performance because you're going to basically overload it with BTUs. There's really not much you can do about it except tell the customer not to do that sort of thing.
Just tell them it's very naughty.
Yes.
Or you could have them just pack it full of dry ice. Then what would happen?
Good things, I'm sure.
Just pack it full of dry ice, and then it solves all the problems.
The human aspect of people that don't know about the equipment working on it kind of creates some more of the headaches too. Because I've seen a situation, and this was with a walk-in cooler, where every Monday, the cooler would be frozen up. And they sent a tech out, and he'd de-ice it and check it, and everything would be fine. And they had to eventually install a camera. And what was happening is when Sunday night, when the cleaning crew would come in to clean the walk-in cooler, it was too cold in there for them, so they'd prop both the doors open.
That's not a good idea.
No. But yeah, you'll see stuff like that, though. I mean, never rule out the human interface of people that are working with your equipment, because I've seen it before. I've seen the display freezers where they're holding ice cream, and there's pull-down little plexiglass lids, and they just leave them up. It has that there for a reason. It's designed to help keep everything in there cold. So you got to kind of be a detective sometimes with some of the stuff. And unfortunately, that's just things that'll happen is some of the people that are working around the equipment don't understand that, hey, you shouldn't prop the door open on this for hours at a time.
And also maybe not even realizing some of the other ramifications, like the moisture side of it as well, that you're going to have copious amounts of ice. So that frosting problem that occurred a day later could very well have something to do with that night before that you left it propped open for an hour or whatever the case may be.
Exactly. It's tedious at times to deal with.
Got it.
One thing I want to briefly cover, and you will see it on some of these boxes, the only thing I see on my list that we didn't cover is pump down. You'll see it a lot more on walk-ins, but some of the bigger reach-ins will have it, where when your condensing unit satisfies temperature, a solenoid will close and it'll pump down. And I mean, your large refrigerant charge, you're pumping it into a receiver instead of letting it go where it wants, because if it does go where it wants, then it's going to go to the evaporator, and when your compressor starts back up, it's going to flood it out. So you will see control strategies where all your thermostat does is cycle a solenoid, and the condenser just reacts based on pressure. So there'll actually be no interconnecting control wires between the condenser and the evaporator. Or not necessarily any, unless it's a freezer, and then the time clock can be wherever they put it. But it's just something to keep in mind. You might not be familiar with pump down and why things pump down, but that's the reason. We don't want all the liquid to migrate to the evaporator in the off cycle and then flood out the condenser when it starts back up.
I've actually seen an entire grocery store, and I'm not going to name the grocery store, where the air conditioning system was set up in that way. And we're talking a massive system. I think it was probably 40 tons, something like that. And that's how it was set up. So you had two condensers, and they had low pressure switches on them. And when it was time to cycle the equipment off, all it did was shut down, pump down solenoids, and they pumped down until the low pressure switches took them out. Needless to say, a failed low pressure switch was not a good thing on that store because it would just sit there and run all day long.
It's the problem. It's not the worst control strategy in the world, but yeah, it's definitely, you don't want a failed pressure switch. I've seen plenty of systems running on that. I think that's actually, we're going off into air conditioning now, but when you start to get into long line sets, one of the first things they want is a crankcase heater. I can't remember the order. So it's crankcase heater, pump down solenoid, and accumulator. And I can't remember which order it goes in. It's probably specific to manufacturers.
Yeah, that order makes sense because a crankcase heater is easy to do. Hard Shutoff Txv is another strategy that's often employed, just a very simple way of managing some of the migration. And in air conditioning, it's a slightly different situation because in that case, it's more likely that you're going to have the refrigerant sit in the compressor crankcase as that evaporator coil warms up, whereas in a box, the evaporator's in a very cold location, so you're going to have all that liquid refrigerant condensing inside that evaporator coil. So it's slightly different, but yeah, it's a strategy that's used, and it's not a bad strategy, but it does have some possible ramifications. But that's something to watch for, obviously. In refrigeration equipment is you do have more of that.
It should be running on pump down if it has a TXV and a decent sized refrigerant charge. And I actually saw one the other day that didn't, and it was a cooler, and it was built up, so that was the installer's fault. But yeah, it destroyed the compressor, it destroyed the valves in it. Not a good thing.
And so when you mention when you have a TXV, it's because when you have a TXV, then you also likely have a receiver. And when you have a receiver, then the system can hold more charge. And when the system can hold more charge, there's more charge that can be stored in the evaporator coil. When there's more charge that can be in the evaporator coil, the more likely you're going to flood out, right?
Exactly. When the refrigerant charges are getting bigger, they're wanting, and then they have to use a TXV, that's when they're going to put a receiver on there because they don't want that refrigerant to be able to migrate.
Makes sense. For technicians, if you get thrown into something like this, my biggest advice would be just to take your time, slow down, understand the equipment, look up some manufacturer's information on it, see if there's any on site, understand how the equipment works, and don't start just like yanking wires off and doing all kinds of crazy stuff because you're probably going to make it worse. Just spend a little time, get to understand this particular product, what type of metering device it has, where the evaporator is, look over it from a cleaning standpoint, and more often than not, I think you'll probably come out ahead even if you don't have a lot of experience with them.
Yeah, pretty much. Don't go by that old adage of when in doubt, jump it out.
All right, Eric, thank you so much. I appreciate it. And we're going to have Eric back on soon to talk about walk-ins as well. I think this has been helpful. I know you have a YouTube channel. If anybody wants to find you on YouTube, how do they go about doing that?
My YouTube channel, it's bad because I haven't been on there so long. I don't post much anymore, but it's Eric M HVAC, and I'm also on Instagram. Actually, I think I'm on YouTube as just Eric M. But just to be forewarned, everybody, there is some adult language on my stuff, so don't listen with your kids around. Just to be warned. Don't
let your 3-year-old go on to Eric M's YouTube channel because they're going to be appalled, shocked and appalled.
Shocked and appalled. And I'm definitely more active on Instagram than YouTube, although I just did post some of that stuff about that 1959 York unit, albeit a very brief video. That thing's kind of cool.
All right, well, go check it out. You can encourage him to get his YouTube channel back up and kickstarted if we just inundate his channel with traffic. HVAC School Army. And all of the mighty minions attack Eric's YouTube channel.
There we go. Then I can monetize it and I can quit my job, retire.
Right. Have you ever noticed that everything's a nation? Everybody has a nation. It's not enough that I'm just a goofy podcaster here sitting in front of my microphone talking about air conditioning. I got to have a nation. HVAC School Nation.
HVAC School Podcast Nation.
Podcast on Fire Nation. Explosion Army. Sorry.
There we go.
All right. Thanks, Eric.
Thank you.
Hey, thanks for listening to the podcast. I enjoyed this one. I think we're going to do more and more in refrigeration as we go. Generally on HVAC School, we really focus on fundamentals. So we focus on again, like I always say, those things that you might have forgotten to know in the first place. Really about the fundamentals, the stuff that's very core to the trade. But there's a lot about refrigeration that seems alien to AC techs, but it's not complicated. It just requires a new perspective and just a few things to remember. So we're going to do more in refrigeration. I also have been begging Jim Bergman to get back on. We've been talking about doing a combustion analysis and furnace commissioning podcast, but he's so busy right now that he just keeps standing me up. So if you have Jim's email, you can shoot him an email, tell him to come on the podcast. That you've been waiting with bated breath to come on, because I think that'll be a really good episode. So keep watching for that in the coming weeks. If you haven't been to hvacrschool.com ever or for a while, I would recommend doing that. We're starting to build up a lot more resources. We have some great calculators. We have a calculator there to show you phase imbalance. If you enter the different voltages of a three-phase system, it'll show you your percentage of imbalance, and if that's a problem, we have a new nitrogen pressure calculator, so showing how nitrogen changes pressure with temperature, depending on when you set it at one temperature and you come back, and if it's at a different temperature, your pressure will be different. So it allows you to calculate what that difference will be. And we have some other things there as well. So it just click around the website. I think you'll find some useful things there. Do a dad joke. I'm just fresh out of dad jokes. Okay. And I think my sense is that everybody, you want to share it with your friends, but you're like, man, I don't know. There's those dad jokes in the end. It's gonna, Brian's gonna make a fool of me, but I want to make a fool of somebody. Jordan Cummings. So Jordan, if you listen to this, I don't know if Jordan actually listens to my podcast or not. Jordan was one of my besties on the HVAC School Facebook group, which, by the way, if you haven't been there, you need to go to the HVAC School Facebook group. That's the best way to interact with me and with the whole crew of our happy admins. A lot of people send me very, very technical, in-depth questions via Messenger or via email, and I really don't have time for that anymore. I mean, if you have things about the podcast, little quick hit questions, that's great, but in-depth stuff, I really don't have time to respond to most of those anymore. And I would love to, but it's just too much at this point. But if you post it on the Facebook group, it's very likely you may get a response from me, but you'll certainly get a response from some other smart people. And again, obviously, it depends on who responds, what the quality of the response. But we've got 19,000 people in the group now, but there's a lot of really smart techs there who can help you. But anyway, so Jordan Cummings is a guy who I've interacted with, and he was a tech in the field, and now he got a fancy pants job with a fancy pants company doing fancy pants VRF work, and I'm kind of jealous of him. But I got to meet Jordan at the AHR conference, and he mentioned that he's been listening with bated breath to see if I mentioned his name. So here we go. Jordan Cummings, Jordan Cummings, Jordan Cummings, Jordan Cummings, Jordan Cummings. All right, there we go. But great meeting you, Jordan, and I look forward to finding a way to meet all of you. I'm looking forward to doing some in-person meetups around the country, maybe some events, that sort of thing. And I think that's going to be fun when the time comes for it. But now we just had this ridiculous had this ridiculous hot snap in Florida. It's like 88 degrees here, and it's February. I know a lot of you are like, you're seriously complaining about that, but for us, we got super busy, and so I got kind of wrapped into that. And my two primary things that I have to do is I have to continue running Kalos. I have to be here for that, and then I have to do this podcast because that's sort of the heart and soul of what we do here. But there's a lot of other things I want to do. Working on a course, I've got some ideas even for a couple other things that I think you're going to enjoy. And for those of you who may or may not have noticed, I do write regularly now for the ACHR News, the magazine, trade magazine that you probably see at. Maybe at your office or at the parts counter. I write in there quite a bit, so if you thumb through those, and you'll find some articles from me there as well. Anyway, thanks for listening, and we will talk to you next time on the HVAC School Podcast.